Morning. Okay, so we can start. So we're looking at the 2.7. Then this is for absolute value. Inequalities. So the absolute values inequalities. Guys on Zoom, can you hear me?
Barely.
Yeah, I had to turn it up, but I can hear you.
Okay, so let's start from absolute value. What is an absolute value? Absolute value. So this is a distance from 0 on a number. So the absolute value is a distance from 0 on the number. So that is the distance from 0 on the number. This absolute value we usually write as of this form. Yeah. So we can write, let's say that one is x. So we write it in that form. So we put 2 lines there. X. This absolute value is greater or equals to 0. It is always greater or equals to 0. That means you take the positive values. So the absolute value takes the positive values. For example, the absolute value of, let's say, -2, this is equals to, that is equals to what?
Positive.
Positive 2. The absolute value of 2 is equals to
Positive
2. We say the absolute value is greater or equals to 0. The absolute value is greater or equals to 0. Now, let's say you're given the absolute value of, let's say, x is greater than 2. The absolute value of x is equals to 2. Then what is x? So what is x? Yeah.
Well, it'd be -2. It's in the absolute value, correct?
Mm-hmm. So what is that value? So this is, so the absolute value of 2 is the same as x equals to 2 or x equals to -2. So you take the positive and the negative values. They can be positive or -2. Because you say the absolute value of -2 is what?
2.
Is 2. The absolute value of 2 is 2. Yeah. So we also say this can be represented in a number. So how should we represent, let's say, the absolute value of 2? So we have the -2 there, and then we have the +2 there. So it will always be the units, 2 units to the left, and 2 units to the what?
Right.
To the right. So 2 units to the left and 2 units to the right. So absolute value of -2 is equals to 2. Absolute value of 2 is equals to 2. So 2 units to the left and 2 units to the right. Now, so what is the absolute value of, let's say, z equals to -4?
We can see it.
Oh, sorry. Absolute value of z equals to -4. Do we have a solution there? So there is no solution. Because we say you cannot have the absolute value to be equals to what? Negative. So the absolute value is not negative. Because we say the absolute value is greater or equals to 0. The absolute value is greater or equals to 0. So we'll see on how we can solve equation of that form. Okay, again, the absolute value of, let's say, w equals to 0, then it is still the same as what? The solution is still the same as
0.
The solution is still the same as 0. So it doesn't change. It doesn't change. Now, how do we solve absolute value equations? Now, how do we solve? So let's try to solve absolute value equations. So an equation has what? An equal sign. So an equation has an equal sign. So, but the expression, it doesn't have the equal sign. So the equation has the equal sign. So how do we solve this? Also, the equation has the inequalities, greater or equals to, less or equals to, that is still an equation. So how should we solve the absolute value equations? Now, if you're given an example of absolute value of 5x minus 4 minus 3 equals to 8. Absolute value of 5x minus 4 minus 3 equals to 8. So how should we solve this? So how we solve this one is we isolate the what?
Absolute value.
The absolute value. Then we take the other ones to the other side. So first of all, you isolate that. So the first step is isolate the absolute value. So that is the first step. So how should we isolate the absolute value here? So we add what?
3.
3. So what we get is 5x minus 4. Now, when we add 3 here, then It will be 0 here, right?
Yeah.
Equals to what?
11.
11. Equals to 11. Now, say the absolute value can be equals to
11.
plus or minus 11, right? So we have two values here. So this absolute value, which is this one, is the same as 5x minus 4 equals to 11, or 5x minus 4 equals to minus what? Minus 11. So we have two values there. So we have two values now. Then now you get the values of x. So you get these values of x here. So we add 4 in both sides here. So you get 5x equals to what? Equals to 15, right? So x equals to 3. Or we also have, we add 4 in both sides. So 5x equals to minus 4 plus, minus 11 plus 4 is what?
-7.
Negative 7. So x equals to what? Negative 7 over 5. Negative 7 over 5. So that is the solution of this. So it's the solution of this one. So we have x equals to 7 over 5 and x equals to 3. Now try this one. Try solve absolute value of w over 2 plus 9 plus 7 equals to minus 10. So w all over 2 plus 9 plus 7 equals to minus 10. So using the same steps, then we start by subtracting what? 7 in both sides. So the absolute value of w plus 9 is equals to what? So minus 10,
-17.
so negative 17. Do we have a solution there? Do we have a solution there?
No.
I don't see a solution there.
Yeah, so we don't actually have a solution because we say the absolute value of, let's say, w equals to, let's say, 5 is the same as what? W equals to 5 or what? Negative 1. Negative 5. And then we also said the absolute value of w is greater or equals to 0. So it should not be negative. So it should not be negative. So we don't have a solution here. We don't have a solution. Another example. The absolute value of 5x plus 9 equals to the absolute value of 9x plus 4. How should we solve that? So how should we solve it? So here we have two solutions again. So we have the 5x plus 9 equals to what? 9x plus 4, or 5x plus 9 equals to minus the bracket of 9x plus 4. So we have two solutions. So we have 5x plus 9 equals to 9x plus 4, or 5x plus 9 equals to minus the bracket of 9x plus 4. So minus is affecting the whole of it. So minus that. Then you solve. So 5x plus 9, you take the 9 to the other side. So 5x, and then you bring 9 to this side, minus 9x equals to 4 minus 9. And this is 4x equals to what? Equals to minus 5. So x equals to 5 over 4. X equals to 5 over 4. Because the minus will do what? Will cancel. So this minus and that one will cancel. But if there was an inequality here, then you switch. Yeah. So the next one is 5x plus 9 equals to. So this minus is affecting everything there. So minus 9x minus what? Minus 4. So you bring the minus 9 to this side. So 5x plus 9x equals to minus 4 minus 9. Minus 4 minus 9. Are we okay up to there? Are we together? Okay, so then what do you get here? So this is 14x equals to what? Equals to minus 13. So x is equals to minus 13 over 14. Minus 13 over 14. Okay. Now let's come to the next section. How should we solve the absolute values of the inequalities now? So let's start from less. So solve absolute value inequalities with, so let's say less. So let's start from less than. So how should we solve the absolute value inequalities with less than? Okay. So for example, let's start by, let's say we have x. So this less than, so less than is both. So you can do less than or equals to less than. So we are using both of them. So we want to start by solving, let's say x, the absolute value is of x is less than 5. Absolute value of x is less than 5. So we know that So we know that the absolute value of x when it is equals to 5 is what? Is 5 or what? Or minus 5, right? Is 5 or minus 5. Now, if the absolute value of this of x is less than 5. Now, so therefore, these values are what? 5 or what? Minus 5. Now, are these values satisfying this? Are they? Are they satisfying that? So we know that x, when x is equals to 5, right? When x is equals to 5, the values are 5 or 5. So first of all, it is satisfying because it is what? It is satisfying the equal side because it is what? It is positive, right? Yeah, so it is satisfying 5 or minus 5. Now, is it satisfying less than 5?
No.
Why?
Because 5 is equal to 5, not listed.
So this is like this in a number line. They are like this. So we have 0 here, and then we have 5 there, then we have minus 5. Okay? We have minus 5. So if it is equal sign, it is 5 or minus 5, which is satisfying now. Okay? Because this sign is positive here. Now, when x is x less than 5, are all values of those x less than 5? So they are within this range. So now the values of x are also less than 5, and also the values of x, yeah, are also within this region. Okay, so they are all satisfying this this value here. All right, so they are within now the minus 5 and 5. So we'll see on how we are going to now switch the signs. So when we have the absolute value of this, let's say the absolute value of u is less than a. So the absolute value of u less than a. This we can write this one s minus a, which is less than u, and also this one is less than. Okay. If we have the absolute value of u less or equals to a, then we can write this one as minus a less or equals to u less or equals to. Now, from this example here, therefore, what we can see is this absolute value, yeah, the absolute value, the values of x are less than 5, less or equals to 5. So to be within this range, then because this is changing the sign, because this is changing the sign to be negative, that means this x will now be greater or equals to minus 1. So therefore, the algebraic notation here will now be x are greater or equals to minus 5, and these are less than 1, less or equals to 5. So this is the algebraic notation. Now, the interval notation will be what? So what will be our interval notation?
Bracket 5, comma 5, bracket.
Yes. So our interval notation, because this is the absolute value, they're within this range. So they're within this range here. So it will be brackets minus 5, and then 5 there. And that will be our interval notation. So this is the interval notation, and this one is the algebraic notation. The algebraic notation. So this is our interval notation. So again, if we have now x less than or equals to 8, x less or equals to 8. So the question can be, write the solution interval algebraic. So how will we write this? So first of all, you start by doing what? Writing x less or equals to 8 or what? So these values are 8 or minus 8, right? So the first one is x less than less or equals to 8. And then the other one is now changing the sign. It's now switching. So it will be x greater or equals to minus 8. So our algebraic notation will be x less or equals to minus 8 less or equals to 8. And our interval notation will now be what? Minus 8 and 8. Minus 8 and another example. How should we now solve x minus 4 less or equals to minus 4? X minus 4 less or equals to minus 4. So what is our solution? What is our solution?
No solution.
So there is no solution, right? Because of the equal sign. So we cannot find the solution here because this should be what? The absolute value should be greater than 0. Should be greater than 0. So there's no solution. Now, how about 5x minus 6? The absolute value is less or equals to 4. So how should we solve this? How should we solve 5x minus 6 less or equals to 4?
Second equation, 4 and equal.
Yep. So the solution is 4 or negative 4, right? Now, this will now be like 5x minus 6 is less or equals to 4, or not or, and, okay? And 5x minus 6 greater or equals to minus 4. Then now, you now get the values of x. So you take this one to the other side, which is minus 6. Okay, so 5x less or equals to 4 plus x, which is there. So x is less or equals to what? 2. And then this one is 5x. Check this one to the other side, greater or equals to 2. So x is greater or equals to 2 followed by 5. So therefore, this x. Okay, so before we continue there, then you need to graph this one. Okay, so you graph it, you see how this one will appear. So how this will appear. So we have, let's say we start by, let's say 1 here and then 2 there. Okay, so this is 0. So we have x less than 2. The values of x are less than 2. So this is 2 here. And this is what? Like that, right? So this is x less or equals to. And then x is greater or equals to 2 over 5. So x is greater or equals to 2 over 5. So let's say it's somewhere. So those values of x are greater or equals to 2 over 5. So x is greater or equals to 2 over 5. So our algebraic notation will be what? So our algebraic notation will be x less or equals to 2 over 5. And this x is less or equals to 2. Okay? All right. So looking at this, this is x is greater than 2 over 5, which is this one. Yep. And then this x is less than 2. Then our interval notation will be what? Brackets 2 over 5, comma 2. Then brackets. So if it is less than, then it will be, if it is less than, then it will be. If it is less than, then it is. And that means there should be the values which are satisfying. Both are satisfying the one, the equation there. So they should both satisfy the equation. So less than is and, less than is and. So they should both satisfy the equation. Now, let's come to the next, which is solve the absolute value equation inequalities with greater than. Now, for greater than. Now, for any algebraic expression, let's say u, for any algebraic expression, let's say u, and any positive real number. And then you take any positive real number, let's say a. So this is the expression, and this one is the positive real number. So this is the positive real number. So if you take those values there, then if x, if let's say u, absolute value of u is greater than a, if the absolute value of u is greater than a, then u is less than minus a, or u is greater than a. u is less than minus a, or u is greater than a. If the absolute value of u is greater than a, then u is less than a, which is changing the sign. Okay. So this one is changing the sign. Or now this is or. Okay. So if it is greater than, then it is what? It is or. If the absolute value is greater than, then we use the or. So one of the values can satisfy the equation. But if it is less than, then it is and. So if it is less than, then it is and. So this is number one. Number two, if the absolute value of u is greater or equals to a, then minus a, oh sorry, u is less or equals to minus a, or u is greater or equals to a. U is less or equals to a minus a, or u is greater or equals to a. For example, let's say we have the absolute value of x is greater than 4. The absolute value of x is greater than 4. So as we have said, then this is what? So this is similar to x is greater than 4, or x is less than minus 4. X is greater than 4, or x is less than 4. Now, if we draw this one in our number, so if we put this one in our number, so this is 0, like that. So we have here minus 4, and we have here 4. Yeah. So x is greater than 4. So x is greater than 4. So when x is greater than 4, yeah. So these are the values, and this one is what? Open, right? So this is x greater than 4. X less than minus 4. So x less than minus 4. Where is it going? Towards the other side, right? So this is x less than minus 4. So how should we represent this in our interval notation?
Would it be parentheses? Parentheses, negative infinity,
Negative infinity,
comma, negative 4,
negative 4,
parentheses, union, parentheses 4, comma, infinity, parentheses.
yes. So that is how we represent in interval notation. So that is our interval notation. Now our algebraic notation will be x is less than 4, or x is greater than 4. So that is our algebraic notation. So this is algebraic, and this one is interval. Any question up to there? Those guys in Zoom? Yeah, mute that. Any question?
I have no questions.
All right. Okay, another example. So let's say we have the absolute value of x plus 3 greater or equals to 5. Are you seeing that? Are you able to see in Zoom?
Yes.
Okay. So how should we solve this? So first of all, you write this into formula. So we know that this one is greater or equals to 5. So if it is greater, then that one is what? That is odd. If it is greater, then that is odd. So if this one is odd, then that means x plus 3 is greater than or equals to 5, or x plus 3 is less or equals to minus 5. So there is 4. So there is 4 there. Now, then you now get the values of what? Get the values of x. So here we take 3 to the other side. So x is greater than or equals to 2. Then here we take 3 to the other side. So x is less or equals to minus what?
Negative.
Negative 8. And then there is 4. So then in our number line, let's say this one is minus 8 and this one is 2. So x is greater than 2. So the values of x are greater than x is greater or equals to 2. So it should be like that. And then the values of x are less or equals to minus 8. So this way. So x is less or equals to minus 8. So our algebraic notation will be x less or equals to minus 8, or x is greater or equals to 2. And our interval notation will be what?
Parenthesis, negative infinity, comma, -8, bracket, union sign, bracket, 2, comma, infinity, parenthesis.
Good. So that is our algebraic, no, our interval notation. That is our interval notation. That is our interval notation. Now, the last one here, last example, say we are given x minus 6 plus 7 greater or equals to minus 1. Absolute value of x minus 6 plus 7 greater or equals to minus 1. So how should we solve that? So first of all, we isolate the absolute value. So we take the other one, the other side. So the absolute value of x minus 6 greater or equals to what?
-8.
Negative 8. Greater or equals to negative 8. Now, look at this.
No solution.
Really? Now, if you look at, if we have the absolute value of, so we said, if it is the absolute value of, the absolute value is plus or what? Minus, right? Plus or minus. But now, in this case, the absolute value is greater than minus 8. Okay? So is there a solution there? Yes, because they are greater than what? Negative 8. They are greater than negative 8. Okay? So you go and figure out that, and then you come and let me know on Friday. So our solution here, because the absolute value of all the positive numbers there are greater than minus 8. All the positive numbers are greater than minus 8. Then therefore, our interval notation will be minus infinity to infinity. So it takes all the values, minus 8 and 8. So at home, you go and figure out how this is. Okay? So as you can know that all the positive numbers there are greater than what? Minus 8. Yeah? So all the positive numbers are greater than minus 8. So therefore, for the algebraic notation, it is all the real numbers. So for the algebraic, so these are all real numbers. So for the algebraic notation, they are all real numbers. All right, that is the end of our section 2.7. So we will meet on Friday and we'll do section 3.1 and 3.2. And then I'll give you a quiz. Cool. So I think there is one person, 2 people who did not do the, who have not done the homework. Eric, you've not done your homework. And maybe you need to do it by the end of the day, because you will get some penalties and it will affect your grades. So make sure you do your homework. So I think there is still an homework for section 2.7, so you can do it by the end of the day. All right. So if there is no other question, then we can meet on Friday. All right, see you guys.
See you.
Okay.